have four very interesting panelists. So we have Fanish Gururaj, who's from Emma. So if you folks don't know, look it up. Emma is an amazing Valley startup, about a couple of years old, I think, roughly. We have Pallavi from Uber, who's building very fascinating, I think, agents in Uber for various kinds of tasks. We have Ramji from Fiddler, head of engineering, which is for Fiddler, which is essentially an observability platform that's out there. And we have Gaurav from Neo. So he's flown in all the way from Delhi. Very grateful that he did that. He started off doing something inspired by the SETI project, but now doing something very, I think it's evolved into something very interesting in the AI inferencing space. So with that, I'll invite the panelists over to get started.
Thanks, folks, for joining here. Very excited, and thanks to Vikram and Venkat here for organizing this. So what we'll be talking about, I think a lot of you might be already aware and kind of got too much bored about agents and AI here. So we'll try to keep it a bit simple from an enterprise angle. What I would like to cover in this next 40-45 minutes is to get insights from Pallavi, Ramji, and Gaurav. And together, I think we should be able to give a lot more insights in what's happening in the agentic AI, how things are shaping in the enterprise space, what are some of the challenges, is there any big opportunities still around, or is it getting consolidated? Let's hear from the experts. Yeah. So we'll start with a quick round of introduction. So myself, this is Panish here. I look at Emma and from the engineering side of the things here at Bangalore. We are in the enterprise space. Over to you, Pallavi.
Hi, I'm Pallavi. I work for Uber. I'm a principal engineer there. So yeah, very much focused on how we build agentic AI at scale for different use cases at Uber, but I'll focus on a few which I'm closer to as we talk.
Hi guys, myself Gaurav. I'm today the co-founder and CTO of Neo Research. Over the last 8 to 9 years, I have been working on building computer vision models, NLP models, and then transition to AI inference, optimizing models for running them on 20,000 plus GPUs, that too in a very distributed manner of underutilized commodity GPUs, using something similar to how SETI did that with SETI at Home project. And then today at Neo, we are developing state-of-the-art machine learning engineering agent for ML engineers.
Hi, I'm Ramji here. I have been with startups for last 20 odd years now. My startup Deep Blue got acquired by Fiddler, and now I lead the Fiddler India site. At Fiddler, we do AI observability. Essentially, like, you are building agents. How do you know? I mean, the thing that I use, how do you know they don't go rogue, right? So yeah, I mean, we can go more technical there, but that's what we do.
Cool. Thanks, folks. Okay, to get some things going here, right? So what probably we can first talk about is, would like to hear some adoption that is happening, what you see at Uber, Pallavi. I know you work in the overall, heading the engineering side of things from customer support and handling Uber's mega scale. So how are you leveraging agentic AI there, both from a tech and business, if you can give us some insights?
Yeah, absolutely. So I'll just paint the picture of overall adoption at Uber. One for the business and one for internal consumption. What do I mean by internal consumption is the bunch of tools that Uber has adopted to make engineers, people, everyone who's working for Uber efficient. And definitely the software lifecycle has changed, and we have adopted a lot of AI tools towards that. GitHub Copilot, Cursor, those are all things that engineers actively use these days to make themselves more efficient. Plus, of course, we have all the companions to summarize our meetings and all of those. So there has been a good adoption across the board, both by engineers, managers, leads, everyone, in terms of tools. Now, business-wise, there are, when GenAI became popular, we were exploring which businesses it makes sense to use LLMs for. We already had models. For example, if you see the ETA models or on Uber Eats, which you probably don't see here, but the recommendation models, we did have a bunch of models. We did have a bunch of NLP models as well. But when we were exploring, we were trying to see which ones fit well. We sort of went broad and said, okay, let's try it out in different places. For example, can we do a chatty interface for ordering groceries? Of course, groceries is available in US or even from restaurants. Of course, customer support was one of the easy ones to identify, and that's actually where we've seen the most gains. One learning was don't force-feed the model where it is natural for people to use natural language, where it is multimodal, where there are images, videos that people upload, where it is multilingual, that is where we've seen the most gain. In fact, if we are trying to use it, let's say, order something in a chatty manner, there it was hard for us to prove the gain or even business-wise. What was the impact that we were trying to build? Yeah, it's interesting, yes. They can try it out, yes. But is there really a gain? Am I getting user loyalty because of that or customer loyalty because of that? Not much, we didn't see much. But however, if you look at on the customer support side, definitely there's a cost benefit, right? So there are things that we are doing that human agents would do. So obviously we're saving cost with the same kind of quality or more or less similar kind of quality. So that's been generally our learning. We've been successful in places. I mean, support was one of the things. Another thing is onboarding. When we onboard drivers, they upload documents. We need to verify the documents. They upload their images, profile photos. Same thing on restaurants, right? They have a bunch of contractual documents that they upload. So all of these image processing, OCR, all of that gets used. So there are places where it adds value. There are places where we felt, yeah, it is nice, but business impact wise, we haven't seen much. So yeah, we're kind of investing more in where we are seeing the impact and reducing our investment where we thought traditional models really work well for us.
Cool. So Gaurav, kind of a good segue here for you. So Gaurav, in terms of, I know you have dabbled in different types of problem statements. So if you have to kind of look at how the agents are moving towards, right, in the enterprise space especially, and traditionally everyone is almost using some of the foundational models or the other, right? Are you thinking in terms of do we need to have a mixture of experts, or are you thinking for this particular domain I need to use these models? Are you building some kind of a router architecture to kind of figure out how the actual agent should be talking to which specific model? Are there some of those things that's being thought through at your end?
Absolutely, that's a great question, and a lot of it has to do with, I would say, in the domain that you're operating. As an enterprise, you might be focused on food delivery or ride sharing, consumer-focused use cases, or specific B2B SaaS, or there are many verticals. So what we have realized is, after building the agent that we have been developing at Neo, to increase basically the reliability of an agent, you need to explore various type of frameworks. For example, there is React framework, there is Kodak framework, and there are single agent workflows along with multi-agent workflows as well. The idea is this, in different domains, different type of architectures would work best, and it can only be derived after doing a lot of internal experimentation. From our experience, what we have realized is multiple agents tend to provide better, you can say, guided workflow, in a way, controlled workflow, in a sense that you can achieve the target that you are aiming for, a particular task that you want to achieve. But a lot of the times, if the models are not trained properly, prompt is not set properly, or like the knowledge base that you have provided to these agents specifically does not carry the right information, they can go into a very long, unbounded conversation, and that leads to massive amount of cost that you don't want to bear. So that is a very core problem with agents these days, that enterprise adoption is not growing that fast. We are seeing adoption as the trend is kicking in. But one core aspect that everybody, especially building in AI agent space, has to work on is reliability. LLMs offer capability, like in technical terms, pass @k. There are k, you can say, factors in which you can make the agent pass in some of them at random trials. But for reliability, you need pass raised to the power k. For each experiment, it should work. You cannot have 80% reliability for an agent that will order the correct food for you. You need 100% accuracy. So in order to achieve that, what we have definitely seen, coming back to the same question that Fanish asked, like mixture of experts, fine-tuning with reinforcement learning can definitely increase the reliability of such agents. And for productionized use cases, specifically in enterprises, we do see the adoption growing faster when we have agents built on fine-tuned models, along with such recent frameworks that I just mentioned in the beginning.
Thanks, Gaurav.
If I may add
Sure,
to
go
that, right? So I think the question came up in the previous session also. Where do you draw that line?
Yeah.
And I kind of use that analogy. I come from a back-end engineering background, so I kind of use that analogy of a microservice. An agent with a single responsibility, like you call it an expert, right? And we call it a single responsibility. And when I say single responsibility, it doesn't mean customer support is a single agent. Even within that, we break it up. An agent to answer facts, an agent to answer, do issue resolution, an agent that can trigger some other automation which is deterministic. So all of these experts sort of come together with a single responsibility. And of course, when you talk about experts, someone has to orchestrate. I think that also came up, that we do have an orchestrator that needs to kind of orchestrate across these experts. So +1 on that, I mean, we are seeing similar trends.
And just to add on that, like the expert, the more specialized the specific, let's say you have 5 separate agents, the more specialized they are in a specific domain or task, the better would be the quality. And those 5 experts can orchestrate the context amongst each other. And how you do that, that is your trick, basically.
No, absolutely. Over to you, Ramji. I think he's the cop here. He's going to do a lot of monitoring and observability here for us. So I know a fantastic journey at Fiddler and really love the product. So Ramji, question to you is on the overall AI observability space, right? I think it's it goes without asking that how do we measure efficiency, kind of eval strategies, what kind of error rates that you see, model drift. All those were some of the things that were there in the ML ops side. Now, when agents have come into picture, what kind of shifts are you seeing in terms of how you're monitoring this overall end-to-end agentic orchestration? What kind of challenges you see and how is Fiddler working towards that?
Maybe I can talk more about challenges than what I'm seeing.
Yeah.
So the thing is, like I'll just draw the journey of Fiddler itself, right? Like we started off with ML monitoring and observability, and then this whole space of LLMs is about 2.5 years, given the ChatGPT's October 22 timeframe, right? And then the whole agentic thing came across. And what we are seeing is we work with mostly enterprises. I mean, probably like very few mid-stage companies, but mostly enterprises. And to what Pallavi said, like the adoption is, I would say, guarded, right? Because you don't know where things fail. And I think earlier Arvind, one of the panelists mentioned, like it's a non-deterministic system and on which you are trying to do some deterministic stuff, right? So from where I see, like the challenges are around that, right? Like how in fact, most of our customers that we try, I can share maybe 1 or 2 snippets of the problem statements, right? Very common stuff is you have around PII and stuff like that, where are you leaking PII? Are you leaking any of those? Then jailbreaks. So these are common, right? Then let's go into slightly advanced use cases. So this is one of the investment platforms. And then if on the customer support, the user comes and asks a few questions, right? Then they should be very clear that they are not doing advisory, right? Because they have to give the information out, let's say some kind of a tax information or whatever, but then they also cannot fall into that advisory side, right? Because regulatorily they are bound not to do advisory, right? So, but how do you ensure that your chat bot or basically the agentic app that you have put out is not doing advisory, right? Or people can, in software world it was all simple, right? I mean, you'll put in some conditions, but here how do you do that? So that is one thing. The other, which I think the whole authentication authorization is going to be challenging. I think for many use cases, we still haven't breached the surface there. But once we go into, one of the things that we were seeing was, let's say I'm booking this flight agent. I'm a user who can do both personal bookings and business bookings. But then when it goes to business bookings, there are approvals. So, but how do you know that agent is going to behave within those boundaries, right? You don't. And how do you even ensure that it will, right? So these are the challenges that we are seeing. I don't have answers. So this is on some of the challenges, right? Now, from an observability perspective, at most of the time, at this point, most of our customers are also focusing on is, and rightly so, right? Because it's around evals. We don't do a lot of evals today. We do post-production monitoring. So on the monitoring side, what we see is that their focus is mostly around traces, mostly around root causing, right? I mean, I think Mahesh or somebody mentioned around if there is an error that occurs, how do you kind of find that, right? So we see that like most of the focus at this point is around how do you kind of root cause if something happens. But even that is not straightforward, because again, coming from software, there if an error occurs, it's an error. Here, it's not an error, right? I mean, but how do you know that if something did not behave? Like tracing it back is harder. The other thing is also different kinds of topologies that we see. Like one of the things that both Pallavi and Gaurav mentioned around mixture of experts, I think that is like also something that we are also seeing. Now the challenge is like this is no longer a call handoff from one expert to another expert. You will see probably multiple loops, or in some cases it may be across, like it may be a hop across skipping something. So how do you even like once you have the traces, even if you have traces, how do you know in drawing analogy to microservices, right? Like there you know it's exactly the path that it will take. Here you don't. So even the debugging part is harder, is what we see. Of course, we are in the space of developing that application. We are still moving forward there. But these are some challenges that I see there.
Cool. So we can just go a little bit deep dive into evaluation, especially at enterprises, right? What happens is most of these business processes or this problem statement is actually working in some capacity. It's not like that particular problem is not being addressed. Of course, it is done by a little bit with more inefficiency, with a lot more people and a lot more stringent processes. And that's where the enterprise agents come into picture to kind of add value. But while delivering that particular product, to do the evaluation, right, is not that very simple, because it would need to be, we need to work with the actual people who have actually been working on that particular thing. And it's extremely very subjective. It always becomes, okay, who's doing better? And there's a lot of difference that happens. Question to the panel here in terms of, if you have to look at evaluation in your current scheme of things, right? And very scientifically, if you have to address that particular problem, what kind of measures you are taking as an org or in your capacity in your team to kind of close some of these evals in a very scientific way?
I can take a shot at it and then. So yeah, evals, very, very critical. Like you were saying, there's a lot of non-determinism in the whole picture. In my mind, I kind of classify it into two buckets. One is what evaluations we perform before we go live, what evaluations we perform after we go live, like post-production and pre-production. So the pre-production ones are slightly easier because we do have the golden data set. We do have some labeled data, and it's mostly comparing, saying, you know, does our system kind of match the actual outcome is equivalent to the expected outcome. So there, most of the investment goes in creating that golden data set. Some of it is automatic. We can synthesize, we can use existing production logs to synthesize the data. Some of it is not. If it's a new use case, you need human intervention. So there's a whole spectrum of, you know, how much human intervention you need when you create the golden data sets. And the post-deployment one, production one, is a critical one, because, you know, observability is obviously the key. And there we actually do a combination of things. We use humans, obviously, there has to be human in the loop to do the evaluation. And we also try to use LLM as judges. And one thing that we've learned is no matter what metric you emit, Ramji, you alluded to the adherence, that is one of the trickiest problems that we've seen to solve. Given a bunch of rules, can the LLM adhere to it? So there it's where we call it the adherence rate of adherence. I mean, is it adhering to Uber policies? Because as for an enterprise, all of these are very, very critical, right? It cannot, for example, it cannot give out a refund like $100, $150, just randomly, right? So it has to adhere to a bunch of policy rules, etc. So when we do that, we have a bunch of human labelers who actually look at it, evaluate against these various metrics. We have a bunch of LLM judges that also look at the same data and evaluate, because humans you can't scale. So we're trying to scale with LLM as judges. And we do, again, within humans, there's a different gradation, if you will. There are people, commoners, who can look at that data and evaluate. There are domain experts who can look at that data and evaluate. The domain experts obviously are more expensive. So we have kind of built a framework called what we call internally U-label. I mean, again, this is out there in public, so you can look it up as well. It's a labeling framework plus a task management framework. So what we do is we sample the production data, push it out into the U-label framework, where a bunch of both humans and LLM as judges evaluate it against a metric. So we do have an SOP against which all of this gets evaluated. And humans, like I said, either you can go with quorum, where we say, okay, 3 people evaluate the same data, and what are they saying? Or you can go evaluator and reviewer kind of a model, where someone evaluates and there's a domain expert who's sampling again. So in spite of all of this, we still take this as a directional metric. What I mean by that is when it says 80%, it may not be really 80%, there's a whole range, because all of these people also differ, LLMs included, humans included. And I don't know how many of you looked at that OpenAI. There was an article where they published for the health records or health suggestions. There are medical experts, doctors who are evaluating what the LLM said. But then even within that, they have a whole range, right? None of them were really agreeing. So there's a agreement rate-wise, there's a whole range. So we say, treat this as directional. Don't say 80% means 80%, it's somewhere around that ballpark. So, but then after that, what comes is the most important part to the root cause analysis. How do we identify patterns? What is going wrong? What are the reasoning traces? Not just reasoning traces of the model, because it's a combination of both deterministic and non-deterministic, right? So what is the data snapshot that you used at the time of reasoning? That also becomes very critical for us. So all of this is logged. And yeah, analysis itself takes a few weeks for us to identify and rectify and all of that. So yeah, being very specific. And one of the other challenges as enterprise we see is also the onboarding of these humans as evaluators. Because the evaluation is not very well planned, you don't know how much you'll get as a load, etc. requirements. So we do sort of have a gig worker mentality here, where we onboard people and say, hey, anyone can come onto a platform, evaluate, label data, and based on the requirement, we can manage the workforce and all of that. So yeah, long winding answer, but sorry, handing off to
That's a good one actually. Just to expand on the point which Ramji earlier mentioned, that specifically around guardrails with like agents, it's very, very difficult to trace back what actually happened and where did it broke down. For example, in LLMs, you have input-output that you can compare with your data set that you have. It becomes a little more easier to evaluate the outputs generated by LLMs. Whereas in agents, the biggest challenge that occurs is the agents are capable of taking actions. Now, let's say there are around 100 actions that were taken to achieve one specific task. Now, at 59th action, it did something wrong because it was dependent on an LLM, which is again a stochastic system. So the idea is this, like, it's very, very hard right now, and that is actually an opportunity, I would say. Like earlier we had guardrails for LLMs, somebody who focuses on building guardrails for agents. That is something that every enterprise who either is developing an agent internally or using somebody else's agent can potentially depend on, can rely on. But the core challenge around here is, I'll give you another example from my personal experience. So at Neo, while developing this ML engineer, we figured out that one way to evaluate whether Neo is performing well or not is the eval metrics for ML engineering, as straightforward as it can be. Like F1 scores, precision recall, AUC, ROC. the typical eval metrics that we have for classical ML and for generative AI. We incorporated that and figured out like whether the model that was being developed by Neo is meeting the target accuracy or not. That became a little more straightforward for us, but the core essence that we later on realized that we had to work on, and today we have matured the systems to such a level that we have complete control over how it engineers the features out of your data. That was one thing that was an insight that came out after thousands of iterations, that why is it choosing these specific features and why not this? Is it because of the LLM is reasoning at that stage, or is it something that has to do with a series of sequences, actions that were taken prior to that particular step? So it's a cascading effect of actions which lead to the current state of the system, and it becomes as difficult as it can be to evaluate why it converged to that particular outcome. And another difficult thing that arises is the more generalized your use case is, the more difficult it would be for you to evaluate for different types of scenarios. When it's a specific use case, the idea is you could have developed a workflow, a chain of LLMs also to do a task. But why did you develop an agent? The core reason is we wanted to develop an autonomous system that could take certain actions by its own reasoning, but also have capability to understand that now I have completed the task and I should end the conversation. So that's a little core difference between what a workflow and agent is in today's perspective. And the more we can control that behavior, the better would be the outcome and quality of the agent. And that's potentially one way to evaluate the agents that you have developed as well.
So I'll just highlight one thing that Pallavi said, right? Like, you mentioned weeks to take the thing, right? And that is very important. Like, I mean, companies definitely are looking to work on that. And at this point, it's still an open problem. The other, which is implicit probably in both of their Gaurav's and Pallavi's thing, is the cost, right? It's not going to be very easy, or the cost of debugging this and getting this right is going to be pretty high.
So she was talking about the traces and looking at the data and stuff like that. But given what you folks do and what we do also, deploying on other enterprise infra where you have to manage somebody else's agents and data sensitivities, how do you do observability, specifically tracing of data, right? Because there are a lot of sensitivities around that. So how do you manage that?
This is just in, to go further. If I understand correctly, you do tracing and you try and do that itself is painful enough. But are you sure that, how sure is the system that the next time the path followed will be same? So what's the point of debugging at all if you don't know that the next time it will follow the same path?
Yeah, reproducibility is the biggest factor actually in agents, right? How, like you do 10 trials, is it repeating the same workflow again and again? That is the control actually, that how do you control the behavior of agent? Because in a singular agent, you still can control a lot more compared to multiple agents, because multiple agents can carry, because an agent itself is like a box containing an LLM, knowledge base, memory, tools, and execution environment. So the idea is just like, let's say there are 5 agents. Now these are, in a realistic scenario, you have 5 team members in your team, and 5 team members with their own thoughts and experiences and knowledge are contributing to one major task. And in at each trial you are looking at, like one of the agents diverges to a different track. So that controlling factor is something that comes from basically either you fine tune the models or apply a solid knowledge base, and usually try to use models which have good if eval score.
One other thing we also do is look at the patterns. I think he alluded to that, right? So basically, Ramji alluded to that, saying, you may not be able to nail one specific interaction and say this went wrong here. It is more about patterns and saying, which agents could be misbehaving here, or which scenarios we might not be seeing the outcomes that we see. But going after individual interaction, I don't think it's worth the effort. Look for patterns is what I think we've generally been following. Sorry, I think the question was directed to you. We hijacked.
In case you want to go ahead. Okay. No, coming to Vikram's question, right? Yeah, this is definitely a challenge. I would say it's not solved as of now. What we intend to do and what is working to some extent is we bake in those things within the product itself. You can call it as reflection in the old days. You can call it as show work. You can call it as reflection. Any of those product terminologies you can use. What that box basically contains is when a particular workflow is triggered, it is going, let's say, through 5 agents before the final response comes. At every agent level, what happens from agent input to agent output, and what is the context being passed. And that is just the factual data. But before that, it would have done a RAG, it would have actually made a search, it would have probably made an action. All those logs, of course, you can see it in your GCP, Azure, AWS logs, all that. But trying to highlight that into the product gives a confidence to, let's say, the product user to say, okay, looks like this particular system tried 3-4 things. And finally, this is the output at this particular agent. Now, it's more of an observation for the actual end user rather than thinking, oh, okay, this output came, now I don't know whether they just put a rule engine or this actual LLM call. So those kind of things can happen. Yeah.
I have a question for Gaurav. So you mentioned the Code Act, right? So did you, were you able to sort of figure out when to use, let's say, code response as opposed to like a JSON response? Is there a, do you have some intuition on that? So that's one question one. The other one is like, does it make sense to use different models across different agents? Like let's say smaller responsible agent could use a smaller model. Or does it have a downside at all if it? And one more question, like how do you sort of pass the context around? Like, is there some intuition on like how can you summarize so that it's not lost when you pass these contexts?
These are really valid questions, and actually we started off with experimenting on Code Act. We realized that it's good for streamlined tasks where the multi-step conversations amongst multiple agents is not maybe beyond, I think it was 18 or 20 rounds of conversations. Beyond 20, it just started to veer off because the code that it generated, the execution environment, the outcome, the evaluation of the next agent based on the output of the first one, everything became a mess. Actually, that just speaking from personal experience, that so we ended up developing our own orchestration engine, which orchestrates the context amongst these particular specialized agents. And we call this, we developed a protocol actually, we call this as context transfer protocol internally, that ensures that the most relevant information. Now, how do we define that most relevant information is something that has come through after so many hits and trials. It will definitely vary depending on the type of use case that you are focusing on. For example, there is Devin for software engineering. There is Cursor. Today they have an agentic workflow as well. The idea is this, like after 25 to 30 iterations, you will see a single, majority of the times there is a single LLM. 200K context length for Claude easily gets surpassed after 25-30 iterations. And when you are dealing with complex projects where you have, let's say, when you started off with a greenfield project, there is no code in that directory, you want to start from scratch. Over there, 30 iterations is nothing. You may even surpass 200 iterations, after which you will realize that the system will realize that like few steps earlier I did something wrong, I need to course correct that. So right. So and that how that like Fanish earlier mentioned about reflection. So this is another concept that you have to introduce in between, and the amount of context that it carries and to which agent it should carry, that is the, you can say, the logic that may change. As per our experience, it had to be very specialized for our use case, but like for general software engineering use cases, there could be a standardized workflow that could be adopted. A lot of the agents today that are, let's say, lovable based, that for web development, for mobile app development, there are a lot of agents coming up. They are following a very standard workflow because unlike software engineering where you define a plan where you have 10 steps to do, you do first, second, third, you are going in a flow. In case of ML engineering, what we realized is it requires a very adaptive and iterative planning. Because after doing 3 experiments with transformer architecture, you realize that for tabular data, this is not working out. I need to go back to XGBoost. Maybe this will work for this particular task. That requires an adaptive planning that we call in Neo as just-in-time planning. So that is something that has been developed by us, and it may vary for different use cases. And for different agents, the choice of LLMs is something that you can decide whether you want to keep them as specialized or narrow, or you want to keep it more generic. Just sharing from the experience again that the more specialized and narrow an agent is, the better would be the quality, the outcome of that particular agent as part of a group chat across the agents.
Question.
So how are you solving for the limitations of vector databases when it comes to semi-structured and unstructured data, especially for hybrid search and multimodal data?
Okay, so no, actually, the idea is this: like a lot of this has to do with the way we have fine-tuned our models. So we are not just using open source foundational models. We are using a mixture of them along with our own fine-tuned models, and we have definitely as Pallavi mentioned earlier, there is a golden data set that works for you, may not work for everybody else, but that is something that comes from a lot of, you can say, analysis about various use cases that you want to target. And the way we targeted them definitely has helped our system improve on terms of understanding, like, this is an unstructured data. I want to fine-tune Whisper for clinical data, let's say, transcriptions. That I have just provided the audio files. Now, I don't even have any mappings of the transcriptions of the audio files with the transcription files. How do you actually make sense out of that data? That is again something that, like, how do you break down the problem statement to such an extent that the system can, you can say, I put myself in the shoes of the person who would be solving this problem. How would I do that? How would I break down that problem? Then only I can impart that knowledge to the agent, either through an instruction tuning workflow or through RL-based multi-step reasoning impartation to the particular LLM.
So how do you handle numbers there? Let's say I'm trying to analyze an earning report, which has a lot of tables, right? And hybrid search, like vector search, do not work really well when it comes to data and in numbers. So how do you handle those use cases?
A lot of the, I would say that a lot of these use cases can be majorly handled with the state-of-the-art models that you have. The coding models, Claude is great at that. So you don't need to super specialize. So one thing that we realized is, don't make everything, if you have a simple solution available, don't complicate that. But for some areas, we realize there are a lot of gaps, which these models hallucinate quite a lot on. So that's where we try to solve with our fine-tuning approach.
And just to add on to that, right? So if VectorDB, we've seen that as well. So if it doesn't perform, we don't even use it for that. That's where expert agents come into picture, right? They collaborate. For very data-focused ones, we actually don't even have an LLM, right? So the agent, while it still implements the agentic interface so they can all talk to each other, a lot of determinism, if you need it in data, we don't even use LLMs there. So that's where all these experts come. You don't have to force fit a solution. Each of them is independent to use their solution as long as they're speaking the same language when they're talking to each other.
Thank you.
Yeah, I think this is Rajesh here. A few questions, I think fairly interesting points made. There's one point that I wanted to touch upon, which is on workflow versus function calling. We've seen function calling improve over the last 6-8 months, right? But the question is, from your experience, are you still on the workflow-based approach, or is function calling already in your own designs right now? That's the first question. The second is on planning. You can feed in static plans versus use LLM for planning. What is that you guys are seeing in your use cases today, right? And the third was on, I think, taking Gaurav's point, that one of the action that you can take after error analysis is you go fine tune. The question is, are there actions like prompt tuning? If so, how are you managing the prompt versions? So on and so forth, right? So what are the various actions taken once you know that, let's say, an agent is needs to be improved, and you've taken the action, right? So
I can attempt the first two. Prompt tuning, we're still experimenting. So
first one is on the workflow,
Workflow.
versus
So yes.
function calling.
yeah, we do use a lot of workflow, by the way. Again, a lot of it comes in where you, at the end of the day, it's not just one function, right? There are multiple tools that you need to invoke, etc. So we do use both LangChain, LangGraph, and some of those frameworks to be able to kind of eventually, a single agent uses all of that.
The second question was on LLM planning.
Yes. So the planner, as of today, we have a sort of deterministic rule-driven one. We are planning to move towards LLM-based, a little more intelligent one. But again, it goes back to observability and how deterministic the whole flow is. Each agent is behaving differently. Now, even the planner doesn't know how to kind of orchestrate, right? So we have seen most success with a little bit of rule-based determinism. Still playing around with the latter one. Haven't seen much success yet.
We're close to 5 more minutes max, I
So-
guess, couple more minutes. So probably
So
one or two
more
questions.
on error analysis and the actions part of it. One of them you talked about is fine-tuning the model.
Yeah,
The
yeah.
other could be prompt tuning, prompt version management. So
Okay.
what is that you're doing there?
Yeah. So I would say, like, honestly, we are not the best ones in terms of prompt tuning. It's something that only has come up as a learning experience for us, because little bit of change here and there can mess up the entire system. And so what we have started doing, the approach I can potentially share here is like, you do small changes in one, let's say there are 5 agents. You make small change, you analyze the outcome and you realize that one of the specific agents is not working. First of all, you have to nail that down, like which particular agents are not basically are causing the core issue. Where are the gaps? Once you analyze that, you will realize that, okay, I need to add or remove something, some context. That could be around how it is handling the file structure, for example, for the code files, or specifically how it is using the environment. Is it using CPU or memory, or is it using GPU VRAM? There are many aspects that you can explore and analyze. And based on that, you do small changes in that particular agents where you see those gaps. And then you do end trials. And then you see how the performance is looking. I think that repetitive trial testing can give you a lot more understanding, although that's the most time-taking and painful process. But that, I think, is the only way, as far as I understand, in terms of prompt tuning, that can help you make your system robust.
So one thing we tried, because we have our own models for safety and all, is fine-tuning works better. Prompt tuning, we tried hand tuning the prompts, and we tried dspy to tune the prompts, but that doesn't result as better accuracy than fine-tuning.
One thing just to add, like in terms of prompt tuning, the models that you choose, there is a public leaderboard for if eval, instruction following eval. The idea is you can potentially start off with models which are good on if eval. Usually, like, the foundational models are pretty good, but if you find something in the open source category specifically for your use case, then maybe you can explore with that also.
Actually, there's more than one question. To the first part, where I think both of you alluded to the fact that how you structure the prompt, is very critical in getting the correct answers. So now, one part of the problem here is the developer who's developing the prompt. He needs to be good in English, or in the verbiage of the problem at hand. That's one part of the problem. The second part of the problem is, once your solution is out in the production, let's say you're building an agent for some customer, and there is end user interacting. So now that person might be a person with very limited English knowledge, and the input text that you've trained your language model may not even fall into, for example, in India, if you're opening your agent to the vast majority of the world out there, so you may have broken English coming in all the time. So your success rate might be pretty poor.
On the first one, there's my personal experience. In fact, prompts can be, I don't know if you call it tuning, but using one of the co-pilots or cursors, we've been able to optimize the prompt itself. to make it a lot more concise, right? Use LLMs for that purpose. They can make it more concise, they can make it more sharp, etc. And we've used that technique often. The second part, at least from my experience, I've seen that it can handle typos well. It can handle, the generic LLMs can handle all of that well, right? Mixed languages. I mean, I'm surprised how well it can handle some of it. Missing words also it can try to figure out sometime based on the context. So I haven't seen the latter as a challenge so far.
And the model ranges, the size of the model ranges you've used, because you've been using multiple models, right? All of you.
Yeah.
So what are the size of the models that you're using in production?
I mean,
In terms of parameter size, whatever, billion parameters, whatever.
we've used, at least like I said, based on the task, we've used anywhere, the whole spectrum of OpenAI models, Gemini models. We have a whole spectrum of it. Again, based on the task is what we generally use. For embedding, for example, we found some the text Python and stuff doing really well. For some of the reasoning models, we found O3 Mini and all of that doing better. So again, it's
The
very
smallest one you've used?
smallest one. We probably no. I don't think we have a smallest kind of a thing. We have used Mini, like I said. That's probably one that takes least number of tokens today. But yeah.
We have worked with 7 billion models. Yeah, so but the idea is just like if you are doing fine tuning specifically, maybe with LoRa adapter, the idea is just like you would have to deploy that as well. The cost of deployment would be very high. So the idea is this for small use cases where foundational models are not needed, you can work with your fine-tuned adapters and you can orchestrate between them. Then like it's more about experimentation. For us, Qwen 3 latest, not the latest Llama, but the previous one definitely worked well. So yeah, like that, it's more about the experimentation that has helped us.
So we also use bird scale models, small models for our guardrails, where the latencies is a challenge, right? Like because we have to provide sub 100 millisecond kind of like latencies, or I mean in some cases and in some 150 milliseconds. So there we use bird scale models, but for the observability side, we kind of use LLM as a judge, where we hit Claude or OpenAI, right?
Let's thank the panelists. I thought that was pretty amazing.